Hi folks, good evening and welcome to the third session of Clean Code or Good Code webinar series, and thanks to IndiaMentor team and Gaurav Arora for giving me the opportunity for presenting these sessions to you. So hopefully we'll have a kind of an interesting session, and it's more of I would prefer to have a more of a discussions rather than monotonous delivery of the sessions. So the source of inspiration is a single most important person for refactoring area is Martin Fowler, and I'm sure many of you guys would have read his articles and being influenced by his books, as I am. So this is the source of this presentation more of. About me, I have worked with .NET from last 11-12 years and now working as a senior developer in Dell, and I have hands-on experience from all those years. So I started with .NET 1.0 and still working right now in .NET 4.5, 4.6 nowadays. I'm interested in all the illicities of architecture and also trying to dabbling with a couple of open source technologies, and these are my social coordinates. Prerequisites is nothing, you should have the interest, and rest is again the same. On a kind of a statutory notice, all views and opinions expressed here are mine and nothing to do with my past or current employer. So let's start the session. So this is the overview for this session. So hopefully it will be interesting. Couple of notes here. Like I tried to put it as a deck or this refactoring deck, more of a thinking presentation rather than hands-on presentation, because it's very difficult to get through all the refactoring techniques or kind of like all the refactoring techniques and show them in a 1 hour session. So we have to squeeze a little bit. So it is not a comprehensive session, but it is kind of an introductory, so get you started session, and hopefully it will invoke you to think towards refactoring, and even if you are practicing the refactoring, it's kind of a refresher for you, and maybe you will still get some of the points and to ponder upon. So that's my belief. So let's see what is refactoring. So refactoring, when I was starting for this presentation, I was a little bit interested in origins of the word refactoring, since definitely it's not only development related or software development related. So I went to Wikipedia and tried to see what is the definition, and the Wikipedia landed me on refactoring talk pages code, talk pages, not code but page basically, and it was more of towards writing and having a description of a talk page. So what it is saying is refactoring is a redrafting process in which talk page content, that is the speech content, is moved, removed or revised, restructured, hidden or otherwise changed. So it applies only in the context where editors make signed statements and has a number of usage, including clarity, improving the clarity, readability, and removing the off-topic unwill. So it's all talking about the about how to deliver the drafted speech basically, and how to improvise on the drafted speech. So that was an interesting starting point for me, and then afterwards, obviously, as I said, Martin Fowler is the guy who has written a book and actually influenced on this specific niche in the technology practice, which is code refactoring. So code refactoring is nothing but it's a amelioration pattern where it says that it is act of relieving the ills or bad things and changing the code for the better. And Martin Fowler, over the period, even Martin Fowler has evolved his thinking and the very definition of a refactoring. So in a version 1 of his book, or in the refactoring book, what he says is, refactoring is a process of a changing software system in such a way that it does not alter the external behavior of the code, yet improves the internal structure. That was his definition first in the book. But if we go to the new refactoring site, he has changed that definition slightly, and what he's saying is, refactoring is a discipline technique for restructuring an existing body of code, altering its internal structure without changing its external behavior. He made it as a discipline now. It's not even like a practice or process. He's saying it is a discipline technique. So, and the most important part for us is without changing the external behavior of the system and only changing the internal structure of the program. So that's what called as a definition of code refactoring. So we can again correlate with the kind of analogies I try to give here with these pictures of a mechanic who is replacing the internal parts of the car, but basically he is not altering any of the user behavior of a car. So basically he is influencing all the external behavior of a car through his internal restructuring, whether it is oiling or re-oiling, or whether it is replacing a small parts or batteries inside the car. He is not anyway altering the external behavior of a car. That is, say, moving from destination 1 to destination 2, or speeding up when you put your step on accelerator, or put a brake, car will still stop. So he's not altering any external behaviors. Same is the case with the watch repairers. So they might tune your watch components and fix it, or can kind of like make it working as expected, so it is still showing the time, even though it is like there are small changes in the internal structure of the behavior. So that's the essence and analogy of code refactoring. So let's see what is also not a code refactoring as well. So there are certain things that we call it as a refactoring, but those are not. And I think before that we'll see the explanation given on the refactoring site itself. It's like, again, I want to stress, it's a small behavior preserving transformation. So it's not a single act or single activity or task. It's a series of behavioral changing or behavior preserving transformations. Again, it can produce a significant restructuring over the period of time, or over the period of this series of transformation. It can produce a significant restructuring of your code. Then why it is important? Because it is less likely to go wrong. Why we choose to go through this technique and this discipline technique? Because there is a less risk to hurt or harm the system or change the external behavior of the system. So let's see what are the now kind of what is not refactoring and what is kind of myths and misunderstanding of the refactoring here. In many throughout my career, we sometimes misuse or abuse this word refactoring. Say, oh, okay, we are doing the refactoring of our project and all those stuff. But let's see what are the myths and misunderstandings. So first is like, okay, we don't need refactoring because nothing is broken, there is nothing to fix it. So that's one of the misunderstanding. The reason behind it is because it's a continual activity, because if we don't improve the software, it will rot. It will be having problems within itself. And what are that kind of problems? That along the line or along the period increases, we keep on adding on the features, it will rot the software. It will make it inflexible. It will make it unmaintainable if we are not practicing the refactoring. Second thing is the notion all these notions like refactoring takes time, then it needs to be planned as a separate activity, then project needs a refactoring. So it's like we are talking on terms of like entire system. Again, refactoring this project will need at least 6 months or 8 months or whatever number of months. That's the kind of a statement that you will hear from the in usual work day. So basically, all these notions are coming from assuming that refactoring is a one-time activity. But refactoring is not a one-time activity, as we rightly see in the definition of a code refactoring. It is a series of transformation, right? So again, there is one more myth which is kind of goes with the mostly often the less informed project managers is refactoring is a rework, but you cannot tag refactoring as a rework because it's a part of making your code better. Okay, so refactoring is not a rework. For refactoring, we need special tools. That's again the demand from the software developer, that there are some certain popular tools that we'll see in the consequent slides. But basically, for refactoring, you don't need kind of a special tools. Your IDE or Visual Studio IDE is good enough. And refactoring can replace the code review. That's again altered truth. Refactoring actually can be also emerged from the code reviews. So that's the misunderstanding and myths about the refactoring. So do you have any questions, guys, till this point? I can see certain questions, so let's. Okay, there is message. Okay, it is from Dan. While you are saying disciplinary approach, does it mean that during refactoring one should follow certain disciplinary parameters? I'm not able to understand disciplinary parameters, but definitely it's a disciplinary approach, meaning that there is a discipline, that is there's a defined steps that you need to do, and there is a calibrated approach to this process. So that's the reason why we are saying it is a disciplinary approach. I hope I have answered. Then Aman is asking, is refactoring mandatory? In my organization, it is mandatory in certain groups. Well, thinking about the refactoring in either while you are development is kind of a mandatory, but as an act of or a result of refactoring, there might not be like you might think in terms of like mostly while we are practicing TDD, refactoring is one of the steps. So it is necessary to think about the refactoring once you pass the test, pass your test. So that is a red-green refactor cycle. So in that, if you are practicing the TDD approach, it is kind of a mandatory. And it is a practice, so the practice can be, we will see in detail. Hold on to that thought. Rocky is asking, who will be responsible if refactoring uncovered bugs in code? Let's say reviewer did review refactoring. Okay, there is okay, and because of this, there are few uncovered bugs on another modules which depends on the refactored module. Well, again, its system is owned by a developer. That's again a kind of a organizational influencing question. But basically, what I believe is system is, and that's how I practice it day in day out, or in our teams, is like we believe that whatever that is our ownership. So there are certain ownership issues also. That's what your question is leading to, Rocky. So if it is the module that is owned by you, definitely you should go ahead and do the refactoring, irrespective of even if it is not your code. Secondly, for the code, sometimes it is also understandable that sometimes you cannot just change the code by even if it is like accessible and technically you can do it. So what you have to do is you can just send the email stating all the refactorings or sending the code review findings along with your assistance. So if you have time and bandwidth, you can straight away ask that particular team to like, guys, I can help you because these are our team findings. So let us know how we can help you. So that kind of thing you can deal with. But this is more of I still believe it is our own duty, like a developer's duty, to do these things or practice these things. So I have answered. The Praful is asking, is it really required for small projects? Again, small. Okay, Facebook started as a small project, Google started as a small project. So is there any definition of a small project? I think whenever, even in my experience, we started a couple of small projects saying it is a POC, it is a throwaway code, and still there are certain components that linger over across the period of time. So it is a 10 years, 20 years period is still there. So I think this question itself shows like we need, for whatever is the program that you are writing, it's a best practice. So if you are saying that whether we should best apply the practice of refactoring to small projects, yes, you should apply it to the small projects as well. Is it reviewer's responsibility if test got failed after refactoring by reviewer? I certainly think, and that's how we practice, is reviewer are kind of your assistants. So the ownership or authorship of that particular code still remains with the though we say it's a shared responsibility, still those other guys who has not written your code or reviewers are actually helping you to identify the defects or identify the opportunities to improve your code. So when you say reviewer change or reviewer has refactored the code, that means reviewer has touched the code, which should not be done. Reviewer should not be actually going back and modifying the code. He can definitely assist the developer. He can sit with him, or he can just communicate that these are the things or these are the methods and classes that you have to write, and sometimes even can provide a solution, but does not mean that he has to fix that particular code. So first, I think in your question, Dan, first I think that's kind of a not right part, and then if reviewer itself is not changing the code, definitely that question will not arise. And mostly in my area or in my team, that's how we practice the code reviews. Who is responsible for refactoring, reviewer or developer? Again, the same question. So reviewer, guys, reviewer is you as a friend and not a code author. Okay, what is the scope of refactoring and who defines the scope? Basically, that's again towards the misunderstanding and myth of refactoring is because why you are asking for the scope of refactoring is because you are thinking that it is a one-time activity and I should get it done as a one task or one thing. So whenever you are adding a feature, whenever you are touching some code, definitely you should look for the refactoring opportunities. So once you see the refactoring opportunities, you can propose those things. So there are various ways to approach to refactoring, and we'll see that things all as well in this presentation. But that's the thing, like if it is not your code, you can still approach the person nicely and politely, and then provide your assistant to fix it. Then again you can actually go ahead, and if you are the owner or if you are team lead or tech lead, you can straight away go and fix that code or ask the developer to fix that code. Again, there are certain ways to do it, but definitely that's how you should approach it. And it's not a one-time activity. Again, code is owned by entire team, so there are certain modules, and in bigger projects or bigger organizations, we have code ownerships and all those parts. But definitely when you go for refactoring, it's not a big refactoring that we are talking here. And in fact, that should not be even the word that you should use for. So if I go to my next slide, actually that will create. So refactoring does not mean re-engineering. That there is a difference, certain difference between those two parts. Okay, so I hope I have answered the question. Let's move on to the next part. So why we should refactor? So basically, again, when we talk about the TDD cycle, normally this word or this practice of refactoring is arise from the, or historically it is discovered first while Ken Beck discovered this TDD cycle or red-green refactor cycle. So why to refactor? Is because whenever we are refactoring, if you have attended the last two sessions, we started with solid principles, and then we see the code smell. And in code smell presentation, what I said is, like when we actually try to uncover, or when we see the, so in reds we write the failing test, or we kind of identify the problem or understand the problem. Then in the green phase of the TDD cycle, we go for writing the smallest possible code which can pass the test, then which is kind of a fixing the solution, and refactoring is kind of a cleaning the solution, where we have opportunity, we don't have a tension. So in the red we have a kind of a psychology that, okay, we have to identify the problem or understand the problem through our test, failing test. In green also we have like a psychological pressure, where we have to say, okay, we have to pass this test. Okay, and if I refer to the Ken Beck's original TDD book, it says do all the things that are required to pass the test, which means whatever you have to do it and pass the test. So it's kind of just finding the solution part of it. In refactor stage of this cycle, what we do is, okay, there is no tension, no pressure. What we see is looking for the betterment opportunities. So kind of a finding or seeking the excellence. So this is the stage where we can take opportunity and say, okay, I have written the test, I have solved the problem. Now, what are the things I can do better here? And how to find those things to do better is through the code smells. Once you identify there are code smells, then we can go for fixing those code smells through solid principles. And again, run all the test cases and find, yeah, okay, we fixed the problem, as well as we did small refactorings which are not changing our external behavior. And by doing all that things, what we are saying, we are making the code adaptable to change. So we are taking a small dividend through refactoring our code and making our code suitable for the upcoming changes. Also, let's see what are the other benefits of the refactoring. So do you remember the first slide where I said all the things that are written by for the speech or scripted speech? So those still apply for our code as well. again clarity and readability, then it just removes all the clutter through your code and it gives you the clarity. It also pays the technical debt. And why you have to technical debt? Because otherwise it will be kind of a broken Windows theory. Whenever there is one window is broken, so if you miss the opportunity, your code or your code smells slightly peek into the code, and there are anti-patterns that are peek into code, and it will eventually start rotting the code. So the refactoring phase or refactoring stage is an opportunity where you can pay the technical debts. Again, you can make your intent clear so that it can improve the maintainability aspect as well. And all these things also leads to the pragmatic design. And why we are doing all these things are because Zen says to move faster, you need to do it right. So if we are doing it right at one thing at a time, then definitely we'll be going kind of a more faster. So I'll take questions here again. Niharika is asking, during refactoring, if I found someone implemented some design patterns wrongly, then is it my responsibility to correct that? Please note, code is working fine and all my tests are passed. I think again, code is working fine is meaning that it is doing what it is expected, which is a functional things or functional features. But you are still, when you are saying that you are implemented, you can see or you can identify that some of the design patterns or meaning code is implemented wrongly. That means you are seeing the opportunities to improvement. So whenever you are seeing the opportunities to improve, definitely you should go ahead and refactor it. TDD is red-green refactoring. So refactoring is a part of TDD. I am not following TDD. Then still can I use refactoring? Perfect. If yes, when? Deepika, hold on to the question. There are a couple of slides. I'll explain it better in the, or you will understand it better when we visit the workflows of refactoring. So TDD is just one way of a refactoring, or one of the kind of a continuous cycle of identifying the refactoring opportunities in a code. But there are certainly, if you are not practicing the TDD, still there are ways to see the code, see the or find the opportunities for the improving the code. So what covers by refactoring? Variable name correction, code correction, anti-patterns correction, cleaning the code, or okay. This also we'll see in the slides. So I'll hold on to that questions. So that's when to refactor. Quite apt question on the time. Workflow of refactoring. So before even going for the when we can improve these things, we need to understand the nature of our code modifications, or when we touch the code, what things happen. So and this is again the source of this slide is Martin Fowler's one of the presentation. So what he says is, whenever we are as a programmer, irrespective whether we are practicing TDD or not practicing TDD, whenever we are as a programmer, we are doing the software development, we are doing two kinds of, or we are wearing two kinds of hats. First is refactoring and second is adding the functionality or features. So what is refactoring hat? Refactoring hat says, when refactoring, every change you make is a change, it is a small behavior preserving change. You only refactor with the green test, and any test failing indicates a mistake by stringing together a series of small changes. Okay, Before even going to the next statement, I'll explain what he want to say in this thing. Even though he is again referring to the green test or test, you can take it as a automated unit test. That's a better way. Even if you don't have an automated unit test, how you in traditional setups when we are not practicing TDD, how we test our program by running it, definitely, right, and checking what are the pages are doing or functionalities or features are doing for that program. So basically we straight away run the program and see it. It's a costlier way, but still it is a kind of a test again, right? So what he is referring is, whenever we change, we make a change, we always make a small behavior preserving change in a refactoring stage. Now by stringing these smaller changes, which are essentially changing the internal structure and preserving the external behavior, by stringing or collecting all these small changes or series of small changes, we can move more quickly and with less risk, because you shouldn't get trapped in debugging. So that's the advantage. And second hat is, or what is the all other changes that we are making to the code is putting into the bucket of adding the functions or features. So you will add new tests and break existing tests. You are not confined to the behavior preserving changes. So whatever that is not behavior preserving, that is not a refactoring. Okay. So during the programming, you may swap frequently between the hats, between the mindsets basically, and you can wear only one hat at a time. So that's what we do always, but we don't realize it, or we unconsciously practice it. We change the code. Sometimes we preserve the behavior, sometimes we don't. And when we preserve the external behavior, again external behavior of a system, then we say we are trying to do the refactoring. And now we'll see what are the ways to refactoring. One already we talked about is TDD, right? So whenever we are actually practicing TDD, there is a refactoring stage in the cycle itself. So we have already, it is embedded in the cycle. So it is nothing but refactoring stage in the TDD is nothing but making it clean. So whenever when we refactor, we ensure that overall code base is clean and well designed, and it is adaptable for the future changes. Now there is another kind of a refactoring that we can practice, which is called as on a broader term, it is called as a opportunities refactoring. Because whenever we see the opportunity, we refactor, or we try to think about the refactoring. And one of the stage is litter pick refactoring. What we do in litter picking, litter means garbage, nothing but a garbage. So whenever we see ugly code, or whenever just now I think one of the attendees has asked a question, or I think it's Niharika who has asked the question, like, when should we, if I see the design patterns is implemented wrongly, should I go ahead and refactor? So definitely yes. So that's a kind of an opportunity presented here, and it is called as a litter pick refactoring. So whenever you see, oh yeah, this code sucks, or oh yeah, this is a design smell, whenever you identify, you should go and try to do the refactoring, and that is called as a litter pick refactoring. Now litter pick refactoring is nothing to do with the TDD. Okay, so even if you are not practicing TDD, you can practice or try to understand or practice opportunistic refactoring. Another one is all the time what we do is and most of the times in maintaining the systems is comprehension refactoring. In comprehension refactoring, what we do is we always say, okay, if any code is presented to you and asked there is a defect in that code, and somebody asks you to, oh okay, can you fix this defect, or you have been asked to fix that defect, then what you do is that area of a code is unfamiliar or that particular module is unfamiliar, and what we do is we try to build a mental model of that code. Yeah, if there is a if statement, this method is calling this method, oh, and this is doing this stuff, or this is changing the configuration or database, or it is adding the, say, payroll record here and there. That's how we build our mental model, kind of our own understanding of that part of the code. So when we build that particular understanding or a mental model of that particular code, what we should do is we should also recreate that mental model or understanding in the code, or try to represent that your own understanding or mental model in the code. So what it means is, whenever you are seeing that things are like whatever the understanding that you had or gained recently, that should not be lost, or that should not be recreated for any other developer. So if any other developer comes and see that code again, he should be able to understand and build the same mental model what you build by gaining or spending a lot of time around that code. So that is called the comprehension. If you do whatever the series of small transformation you do to build that mental model of yours inside the code, that is called as the comprehension refactoring. Another one is a preparatory. Now in preparatory, mostly it is practiced when we are adding the new features or trying to actually enhance one of the features which is already existing. So in preparatory refactoring, what we do is we try to cram the new feature or new enhancement. Say the taxing system is there, and we are already having a feature whereby we do the taxing of invoices for US, UK, and Canada. And now we are making, or we are asked to make it the same feature for, or same taxing feature for India. So that's kind of we are trying to cram the feature again, which is something similar of existing feature. So we need to first do small changes to fit this feature, right, here and there. So that is kind of a preparatory refactoring. That is your opportunity for doing the preparatory refactoring. Now you can take analogy of for preparatory refactoring, you can take an analogy of your denting painting of your car. So suppose or say you wanted to have your kid sitting next in the car. So what we do, we provide him a booster seat, right? So that's kind of a analogy for the real world analogy for the preparatory testing, refactoring. Got it? So in a way, we have the when question is answered. I hope so. Right? Now the next question what arises for us is, okay, we understand when to refactor, but what we can refactor. So definitely we always think in terms of a code. So whatever the source code that we write for satisfying the features or creating or enhancing the features, that's the one we can refactor. But in a more traditional TDD sense, or whenever we are even thinking about any of the refactoring, whether it's an opportunity, even if we are not practicing the TDD, we have opportunistic or preparatory, then there is an opportunity for also refactoring the unit test cases. Those are the conventional things, but you can also think about unconventional things like database queries or database schemas. Then your assemblies or packaging arrangement in the system, as well as configurations, API endpoints, network data that is flowing over the network, that database schema or data structure schema, integration tests. Those are the avenues, or those are the things that you can refactor, or you can think about refactor. It's just not the code that you are writing for the satisfying the feature or enhancing the feature. Okay, and if Okay, now next is refactoring principles. So while doing all, like we saw that when we can refactor, what we can refactor. Now we'll see what are the what are the principles that we have to apply while we are doing this activity or while we're carrying out this technique. So first is drag, which is nothing but do not repeat yourself. What it says is like whenever you are, so in simple terms, what it is trying to say is whenever you are refactoring, try to avoid or try to remove or eliminate the duplicate code, nothing else. Okay, so that's the one of the thing that you should also try to target when you are seeing the refactoring opportunity. Second is Yagni. Yagni said you gonna need it, and it is almost falling in the lines of TDD, because we write the passing test only to satisfy that failing test. Okay, nothing much, nothing less. So we don't like keep a provision of or keep enhancing the feature to just satisfy our need, or so we are not going for the over engineering stuff with the Yagni principle. Second is the next one is keys, that is keep it simple. So again, it's we should avoid the writing the clever code, and we should always write a clear or intent revealing code. Then boy squad rule. Boy squad rule says is definitely it's a very simple but very powerful rule, and even if you can practice it anytime. Basically, boy squad rule says that whatever you touch, whatever the part of the code that you touch, you should leave it slightly better. So whenever you visit the code and you see there is, okay, it's not good and it's not the perfect also, you don't try to strive it for getting it best, but you should strive it for getting it better. So whenever you are leaving or closing that file, you should at least see some better thing. Maybe if it is not 100%, so if there are like 500 lines of a code in the method which is very hard to understand, and you try to just debug the code and try to solve the defect, then what you should do is you should at least try to make it into 2 methods or 3 methods, just slightly better, not perfect. Okay, perfect maybe like enhancing the classes and all those stuff, but no, you should just leave it within like creating 2 methods. Again, if you in future some other day you revisit that code, then think the next small opportunity. That's all is about the boy squad rule. Then definitely solid principles is kind of, because then in a refactoring stage, as I said in a code smell presentation as well, whenever you are in a refactoring stage, identify the code smell. Don't try to apply the solid principle directly to your code. Identify the code smells, then code smell, with the code smells, through refactoring you can implement the solid principles as well as design patterns. And one of the greatly helpful practice along with the refactoring principles is pair programming. Definitely you are writing your code for other human being to understand. Okay, it might be you yourself after say 5 months or 2 months or 2 days, and once you get a extra pair of eyeballs, then definitely it is a different brain. So with collaborating with other human being, you can improve that code or try to make it better. And if you okay, I want to revisit again on the keep it simple principle. So if you, what I mean to say here is like whatever the clever code and intent revealing or clear code is, this is the kind of a clever code people write, and they and some other developers are having hard time while understanding these kinds of code. This is nothing but a clever code, but it is doing the functionality, it is working fine, but still it is not actually maintainable. So let's go for the questions again. Okay, now Deepika is asking TDD is red green refactoring, so refactoring is a part of TDD. Okay, I think I have answered this. Then Neha, what covers? I think I have answered to this as well. Aman is saying, okay, Aman is saying, I'm working on a fixed bid project and having timelines. I know a certain improvements required. Now how I perform or ask my seniors for refactoring. Okay, so Aman, I can answer you with the analogy. Hope everyone understand, and this is very important because this is the practical scenarios we have to convince our bosses, managers, senior people, or whoever it is, other developer who are not in who are in argument with the refactoring. Is there are two analogies I will tell you. First is technical debt. So you should actually try to Google on the technical debt, and the metaphor says that if your code or whatever the bad thing that you are trying is kind of taking a debt on yourself. So when we take the debt, what happens is we have to pay the interest. If we are not paying the interest, what happens is bank will seize that property, or bank will actually take the ownership of that property, right? So you will lose, it's a lose-lose scenario. It's not a win-win scenario, right? So that's the one way of convincing whoever you want to. Second thing is, for even if it is a fixed bid project, or even if it is whatever the model you are practicing, time and material. Second analogy is more harsh, or I mean on the problem, right? So second analogy is like what you're asking is, okay, I have a short period of time and I want to do it right, so should I skip the most necessary part of it? So it is like, say there is a heart patient, or there is a heart patient, and you are rushing to the hospital and asking for the doctor, hey doctor, you don't need to worry about your own hygiene and cleanliness. You don't need to use any kind of cleaning material or even put on the gloves, and even you don't need to actually clean up your articles or instrument from other operation, and straight away you can use it because that will be faster. Will it be okay if some surgeons do that kind of stuff? No, right? So meaning, if this is the ethos of a professional, so you need to practice those things. You cannot just keep because there is some business is demanding to compromise on a certain factor. Now it is, and if you go by, if I will, why I told you these two analogies is because the doctor's analogy is right fit for the technical person. If you are, say, trying to convince the technical person, you can actually use the doctor's analogy, and for the bank analogy or debt analogy, you can go for the business people. So that's how I always go for convincing the people, or whether it's a business or whether it's a technical community. But the major point or critical point is you have to do it irrespective of your business model, because anyway, if it is a fixed bid project, you want a repeat business from your customer, right? You don't want to be closing that as a transaction. So I hope Aman, I have answered your question, not directly but with metaphors. Please repeat dry. I didn't get you. I heard you wrong. What should I do? I found repetitive code during refactoring. Dan is saying I talked something wrong about dry. But dry, it says that do not repeat yourself. So we need to remove the duplicate code, which is unnecessary. So you need to remove the clutter. so that if it is a problem, we can actually understand that problem and it can be exposed. Secondly, it is also, we can focus on the right parts of the code, and less the code, the best maintainable code is whatever that you don't have to write. Okay, so I think we can move ahead. So refactoring tools, again, somebody has asked this question. So there are certain tools in the market which help you to refactor your code, but mind well, these are the automatic suggestions tools. So again, those tools will give the suggestions, but you are the right person, or you are the actually person with brain. So you have to take the decision what refactoring or whatever the suggestion that these tools give to that you can implement. So the tools in Visual Studio itself, we have a refactor in a context menu. If you open any C# or file, you can find right click. If you right click in the context menu, you can find the refactor sub menu, and under refactor you can find the most useful refactoring technique, that is extract method and organize. There are some others. Resharper is kind of again favorite and popular, most popular maybe refactoring tool in the .NET community. Code Rush is there from DevExpress, Just Code by Tailoring, and nowadays even SonarLint is there, which is provided by SonarCube or SonarSource. So those are the tools. Now let's go to the refactoring techniques. So before going for the refactoring techniques, if you have any questions, please let us know. So I think we can move ahead. So in refactoring techniques, what we see is there are certain techniques. I have grouped those techniques according to the intent of those techniques. So when we are saying when we are going for these techniques, understand that I'm not going to go into the details of those, like how to practice that technique or how to actually carry out that technique using Visual Studio. The very reason is there are various and maybe better code articles on the internet, as well as videos which you can see and practice those techniques. Even there are sites only dedicated to those techniques. So in abstraction focus technique, encapsulate field is there, whereby which we force the code to access the field with the getter and setter methods. Generalized type, so it's like extracting the generalized type out of the code. So this is also a way of removing the duplicates. Then replace the type checking code with a state or strategy. That is one. Again, replacing it with the dictionary is also other one. Then replacing conditional with polymorphism. It is nothing but polymorphic dispatch, implementing the polymorphic dispatch. The isolation focus technique. So you need to have a isolated component or a sandbox kind of environment provided for that particular class or method. So these techniques, these refactoring techniques will give you that sandbox or safety net. So it is nothing but a componentization. Extract class is one of the technique, then extract method is one of the techniques, whereby which you can extract the larger method, pull out the method, and then break it into the smaller pieces. So it is easier for, it reduces the cognitive bias and it is easier for understanding it. Then there are some intent revealing or code clarity focus techniques, which are nothing but move method, move field, rename method, rename field, pull and push the features. So And if you visit this site, which is refactoring.com, and you will see the long list of it's a catalog of refactoring techniques, whereby every technique is explained bit. But and there are so many resources available on the internet that I didn't even, which are explaining better than me, so I didn't want to even go into the details of it. But there is one value I want to deliver through this webinar is, of course, you don't need to memorize everything here, whatever that is given in the catalog, okay? Or you don't need to even memorize these techniques. What you need to understand and memorize is what there are certain elements that you can practice, or even it's your team can be actually practice it collaboratively, and those are called as the refactoring thumbnails. So what are the refactoring thumbnails? It's kind of a almost forgotten technique in the refactoring, so you will not even find much of the material on the internet about it, and very few people are practicing it. But it is very easy, and very if you practice or if you try to understand the entire catalog through the thumbnails, it will be very easy for you, and you will be able to easily understand the techniques, all these catalog techniques or catalog methods. Basically, those are the practices that you have to do. So why refactoring thumbnail? Because it expresses it is a visual technique. So you will understand or will represent all our systems, or that are part where we see the refactoring opportunity, that code bases or code parts or components or modules as a visual diagrams. And it is a sequence of a high level refactoring. It is presented in intermediate stages. Now the most important part, what I believe which is missing with this catalog is, or when we do or all other sources are missing, is we can see all the time, like time sequence of how the code has been shaped. So let's take an example, and why to do it is we'll come back to this slide. So let's take an example. So say suppose we have started with a copy paste code. Okay, so that's the first stage, in the diagram that is representing. Then what we are saying is we have implemented the inheritance. So this is the common code which is represented by the blue lines here. So this code is actually, we extracted it, we pulled it out in the next stage. So it sits in the super class or base class. Then the next is, it's a passing of the intermediate state here, and it ends with the interface based solution. So it is an interface. So what we do here is we along the series of a small transformation, again over the period of time, we deleted or eliminated the duplicate code which were presented into the two components or two modules of our system, or two classes here. Okay, now this transformation is actually very well represented by the refactoring thumbnails, and this is called one of the thumbnail. Okay, why we have to practice, or why we have to understand or practice more using thumbnails, is because it is very clear and pragmatic. Okay, secondly, you can discuss these kind of diagrams. You don't need tools and anything with anybody in your team. So it is a single unambiguous channel or communication technique that you can practice, and that way if something is going wrong, you can actually, or your colleague can actually spot it somewhere. Okay, yeah, this stage is not correct, so we can actually, he can propose his own other solutions. And since this is not an actual code that you have already implemented or sent for the review, it is very easy to practice it, right? It is very cheap, or it is it is really cheap, and you can throw it away and again go for the another solution or solution approach for this refactoring. So that is the reason you have to practice or I will prefer you to practice the refactoring through refactoring thumbnails. And it is very easy to understand or think about the refactoring through the refactoring thumbnails. Now there are certain other kinds of when you have a series of thumbnails, you go to the evolution chart. So this is the example of a refactoring thumbnail. So moving a feature. So there is a standard in a catalog also it is listed as a moving a feature. So it's a push down of a method here, that kind of a refactoring. So here we have a user window class where we have calculate year interest method, and there is also another class which is extending or implementing. This is Java example. So this is extending the JFrame. So this window class is actually inheriting from the JFrame. So what is happening is actually this class is there, then there is an account class which is still there. So this method which does not belong to user window class is actually pushed down. So it is extracted and then fitted into the account class. So this is nothing but a moving a feature. So we have like this was the feature of calculating the year interest, and that is moved to the account class. This is nothing but a push down or moving a feature. Again, like definitely you can actually practice the moving up as well. And this is nothing but a refactoring thumbnail. Now we will see the evolution chart for eliminating the duplication by composition. And see, you will get the benefit here. So we have two classes at initial stage where we have a similar code. Okay. So what you can do is you can practice the standard technique called as the extract class. So you can extract a class from this, okay, this first class, and then the next transformation is retrofit this extracted class into other class. So the next one is actually cutting this or removing or eliminating this similar features, and then actually moving it to the shared class or the new class. That's the one flow or one way of a refactoring. Another way to reach again to the same state of the organization of these classes is you can extract class into, like, okay, somebody has created the class here, so extract the same portion of the class, then unify that class. So you can also reach through this way, right? The third way is you have actually all the features, you create another class, but you don't extract the features here, right? In the next cycle, you extract one feature in a shared class. In the next cycle, you extract another one, and that way you can reach till the same point. Okay, so this is the first starting point of your system. Okay, and this is the end state that you can achieve by 3 different ways of carrying the refactoring. Now in real life, what happens is you will not able to go to from this. Sometimes you can say that, okay, in diagram it is very easy, you can see, oh yeah, there is a duplication of a code, so I can create a code and straight away land it here. But that's not a refactoring, right? Because we have to go for the, without changing the external behavior, we have to go for the transformations. Why? Because there is a less risk involved. And sometimes also the question has arises like whether it's my code, it's not my code, it's my team's code, not my code, or otherwise I don't have time to refactor all these features, right? This common or shared duplicated code might be huge as well, right? So we don't know. So over the period of time, you can take any of the approach and still reach to the same destination, which is a decoupled code, right? We remove the duplicate. So that is the value of and all you can discuss, okay? All these you can discuss with the evolution chart. So what I'll suggest is, instead of trying to go through all the hoops of understanding and remembering all the techniques or all the techniques given in a catalog, understand what you can do. And if you practice these principles in a refactoring stage, which is dry, yagni, keep it simple, Boy Scout rules, solid principles, and if possible pair programming, then definitely you can actually achieve a greater value even without trying to remember all the things in a catalog, refactoring catalog or refactoring techniques given in a different sources on the internet. So I think that's the end of the this webinar. But in a summary, in a gist, what I can say is refactoring is continuous activity and not a one-time task or one-time activity. So, and it's again part of a development workflow. It's not something that you should be carrying. If there is opportunity, I mean, whatever that code that you touch, you can see the opportunity, you can straight away go and refactoring. Now, if you do not have the test cases of you, or you cannot run the system and cannot test it, that's the way you should. So in a meaning, if you don't have a safety net, then that's the kind of a alarming bell. So you should not go ahead with the refactoring in that stage. Refactoring is not a re-engineering. Then by definition, refactoring needs tests to verify the external behavior. That is very important point, because that through the test, whether it is automated or manual, you can actually test the entire external behavior of the system. Refactoring tools are extremely helpful, but those are not mandatory. Like we have seen with the simple charts, evolution chart or refactoring thumbnails, we can explain the things and we can carry out those refactoring without any kind of a tools. Of course, tools are quite helpful in keeping the code hygiene. Okay. Refactoring techniques are better visualized with refactoring thumbnails and evolution charts. And why we have to go understand or practice the refactoring is because through refactoring we can achieve the clean code along with the solid principle, code smells and all those understanding of all these things, and you can go for the faster delivery. So even if your project is a fixed bid project or time and material or whatever the model that you are practicing, it is very important to have a collective or a common understanding of these techniques, and through which we can deliver it faster and deliver it with the quality product, so that our customers will repeat and they will give a more business, and who don't need a more business, right? So I'm done with right now with my webinar. So if you have any questions, we can still take the questions. I'll be here for next 10 minutes. So yeah, floor is open for you guys.